Similar triangles are an important topic. They're on almost every ACT, and thus far they've been on every one of the new SATs, just in case you're kind of doing both. So let's use my friend the 3, 4, 5 right triangle as an example. Similar triangles are triangles that are the same shape. They're just different sizes, different scales, like an enlargement or reduction on a copier. What that really means is that they have the same interior angles. They have the same interior angles. So let's say this triangle is a 6, 8, 10, which is just a multiple of a 3, 4, 5. It's literally twice the size of this triangle. Okay? And the ratio of the hypotenuses of the small triangle to the big, 5 to 10, is the same as the ratio of the short side to the short side, 3 to 6, and the medium side to the medium side, 4 to 8, 1 to 2, 1 to 2, 1 to 2, if you reduce that, right? Simplify it. These are called corresponding sides. They're opposite the angles with the same measure, right? These two angles have the same measure. The sides opposite them are called corresponding sides. Obviously, these two angles have the same measure, corresponding sides. And let's switch colors. These two angles, right, are the same, corresponding sides. You'll notice, if you recall from the material, and I hope you do because it's really important stuff, I'm starting like that vertical method of proportion solving that I do. If you have a similar triangle question, it's really always going to be a proportion question. So you're going to solve it using ratios pretty much every time. I cannot think of an exception. One other note, this does not work with area, right? This does not work with area because with area you're multiplying things, and you'd have to multiply the conversion factor, which in this case is the ratio, but don't worry about that. I'll talk a little bit about that in units, but it does, this ratio will hold up for perimeter. Let's look. So 3 plus 4 is 7, plus 5 is 12. 6 plus 8 is 14, plus 10 is 24. So the ratio of the sides is consistent, and so is the ratio of the perimeter. Doesn't work with area, though. Okay, so let's flip into a full screen ACT problem, tackle one of these, and go from there. The first thing I want you to know about similar triangle problems on the ACT is they're not usually labeled similar triangle problems. Kind of got to figure that out. So let's look at the question as a clue. The triangles below have lengths given. DE is parallel to BC. What is the length of AD? So if they give you two triangles, they ask about a length of one, or they compare them in a ratio or fraction, or their perimeters in some such manner, then you're talking similar triangles, almost always. Or even if they ask you about the ratio of the areas, that can also be a similar triangle question. Now, I have to prove that they're similar triangles question, not only to be able to use similar triangles. I mean, if it was stipulated, if it was stated they were similar triangles, I wouldn't need to do this. But by showing myself that they are similar triangles, I know I'm on the right track. To know that they're similar triangles, I got to know that the interior angles are all the same. To know that the interior angles are all the same, all three interior angles on both triangles, I have to know that only two of those angles are the same. So we got two triangles. We got this little triangle that's a component of the big triangle, ABC. So little triangle ADE is just a part of ABC. Now ADE, my little triangle, shares an angle with ABC, this top angle. Well, they share that. That's going to be identical. So I only need to show one more is identical. Parallel. If you watch the angles videos, I really tried to reinforce how important parallel lines are. And here they come into play. So transversal, transversal. It's hitting this parallel line, that's hitting this one. These angles are going to be the same, and the same is true on the other side. So I'm actually able to prove all three of these angles are identical. Now that I do that, now that I've done that, it's nice to label my angles a little bit. Maybe I could do all three sides if I want, or I can start labeling sides. I mean, there's several ways to do it. You may want to play around with your own notation system, but I'm ready to go ahead and set up a proportion, and I'm going to set it up as small to big, and I'm looking for two sides that I know. Remember, whenever you solve proportions, you need to start with a complete ratio. So I know that this DE and this BC are comparable, right? They're corresponding sides, 3 to 5, My next line is going to have the thing I know and the thing I don't know. I'm looking for AD. What corresponds to AD? 7. 7, and then this is X. Right? And then what do? I start making fractions. Please review proportions if you need to. This is my method of solve. Oops, I went too far over, didn't I? Can't write that far. Try again. This is my method of solving proportions, and I think it's very effective. Remember, about 10 or even greater than 10% of the entire test can be solved using proportions. Got these two fractions equal to each other. Cross multiply. 5x equals 21. Divide by 5. X equals 4 1/5, or 4.2. All there is to it. So what were the steps? First, I had to figure out that they were talking about possibly similar triangles. Second, had to show to myself that they were similar triangles. Both of those steps just because they didn't tell me they were similar triangles. Third, I had to set up the proportion and then solve it. That's all there is to these. Don't let them trip you up. They're just geometry proportion questions. So check out the right triangle stuff. It's really important.